Okay, so we're going to start the second part of our event. I'm excited to invite these great panelists, and Luca Donald is going to moderate Proof It, a call for collaboration to improve fraud proofs. Okay, so I wish you all good luck, great conversation. And after this panel, we're going to have a Belgian beer tasting experience, so please don't rush to leave. Stay for a while, have a good conversation, have a good beer. Okay, all the best.
Thank you. So let's go with the usual round of introduction. I'm Luca. I work at L2Bit in the research team. And what we do is that we try to assess the risks of all the L2s up there, including the protocols of the people that are here on the panel. And one thing that is very complex for us is actually understanding what is going on into the proof systems of these projects. Proof systems are usually very complex, both ZK and for proofs. So it's very important to understand like the trade-offs that the systems are making. So we're here to talk about fraud proofs. Specifically on fraud proofs, it appears that there is a fundamental trade-off or a fundamental trilemma when discussing fraud proofs. So the initial idea, or like what we usually like to say, is that fraud proofs have this one single honest challenger assumption. So we have the assumption that as long as there is one single actor that is live and willing to challenge dishonest state truths, the protocol is safe. But actually, in most of the designs, which is 2 out of 3, because we have 3 designs on fraud proofs for L2s, at least, it appears that it's not actually a 1 out of n assumption. It appears that the trade-off is, like the assumption is a percentage of the funds that the attacker has. And this is called an exhaustion attack, or a Sybil attack on fraud proofs. And like to give you a bit of background, I can explain it with an example. So let's say that we have a fraud proof mechanism without bonds. If I am an attacker, I can just start to publish a lot of invalid state truths. The honest defender has to challenge all of them, right? And by challenging all of them, I mean, it needs to go into the bisection game, it needs to do multiple operations on L1, and these multiple operations require funds. Like there is some cost into going into the bisection game. And if the attacker has more funds than the defender, it can exhaust the resources of the defender. So if the attacker has more funds, it can win the fraud proof game. So actually, it becomes a race to who has the most funds. Then what you can do is you can add bonds. You can maybe skew the protocol to favor the defender by using bonds, right? But then when you want to add bonds, it appears that you hard decentralization, because then you might need higher bonds, and then not everyone can participate in the protocol because maybe they don't have enough funds to protect the chain. Or maybe you can go into another direction when you hard what we call promptness, meaning that, yes, you can lower the bond requirements, but then you require a very long period. So we'll go into the details of this trade-off. I want to start with Ed, because I read the first version of the Bold paper. So the Bold, my understanding is that the Bold protocol is trying to solve the issue that the current challenge protocol that is live on Arbitrum, the issue that this protocol has, which is that it is affected. It is affected by Sybil attacks.
Yes, that's right.
One attacker can create many Sybils and delay the protocol for n challenge periods, if it's willing to burn n stakes, right?
Yes.
So Bold is trying to fix this issue. The first version didn't really explicitly talk about like extortion attacks or Sybil attacks, but then the full paper has like a very big section talking about it, right? So what's your perspective on this trade-off?
Sure. Let me talk about it in a bunch of ways. But first, some level setting, right? We're really serious about when we publish a protocol, having a specific threat model that we write down, declare, so everyone knows what it is, having a set of claimed properties for the protocol, and having an argument as to why the protocol provides those properties within that threat model. For us, that's table stakes. If you haven't done that, then your protocol isn't ready. So we have this analysis here, and there's a couple things that you can do. You need to be also careful that you don't create a situation, which some protocols do, where an attacker can stage a fake dispute against themselves, where they take both sides, and this burns time, but they end up recovering their funds. For example, if you make the mistake of giving the loser's funds to the winner, then there's a zero-cost attack that buys delay. So you don't want to do that either. And again, some protocols do that. So what do? There's a couple things you can do. One is you can think carefully about the protocol design and have variable stakes at different points so that the attacker has to stake asymptotically more than the defender. And of course, the defender will get their money back, but the attacker will lose theirs, right? And you try to optimize that curve and so on. There's a whole lot of theory. If you love this stuff, you like the middle 20 pages of our paper. If you don't, then just let me assure you we sweated the details. That's number one. The other thing you want to do, which also Bold does, is allow trustless pooling of stakes. That is, a group of parties can get together, and they can have a kind of Kickstarter for staking, right? If I have a tenth of a stake and 9 other people have a tenth of a stake, we can combine them via a smart contract completely trustlessly, so that as long as I know I'm staking on the actually true result, then I'm good. And once somebody stakes honestly, then other people can act within the protocol without also staking. You just need one honest stake to be placed at each point in the protocol, and then other parties can defend that. So, there's a lot you can do. But the bottom line is, if you're relying on staking to deter delay attacks, then you're going to face this issue. And if you don't think you have this issue, then you need to analyze your protocol more.
Yeah, so I just noticed that I didn't finish the round of introduction. That was very rude. So let's do it very quickly. Ed from Arbitrum, John from Celestia. And so what's
Mark?
Mark from Optimism, Justin from Bitcoin researcher, security researcher from the Ethereum Foundation, and Gabriel from Cartesi. So let's be a little bit more concrete. What is the bond requirement on Arbitrum right now, on Bold?
Yeah, so the bond requirement, basically, there's a top-level bond requirement, and then there's sort of sub-bond requirements. The top-level bond requirement is 3,600 ETH. And the reason for that is in all of these protocols, at least properly designed protocols, there is an easy attack where an attacker puts down one stake and they buy 1 unit of delay, right? And the question is, how much do you need to deter that? Right? You need to deter that attack, an attacker who's willing to sacrifice 1 stake, have it completely burned, not go to their confederate who challenged them. And the question is, how much do you need to deter that? Right? The more value there is at stake in your chain, the higher that has to be. Now, that's why stake pooling is so important, right? And also why the Arbitrum DAO is being asked to provide, to essentially lend a stake for this purpose. And stay tuned for further developments. There will be improvements in this area.
So there is one aspect that I don't fully understand regarding Bold, because I saw this economics.pdf document explaining why the bond requirement is so high.
Yep.
And the reason is that, as you said, you want to estimate the cost of delaying the protocol by calculating the opportunity cost based on interest rates, right?
Yep.
But another thing is that you have a multi-level challenge protocol, right?
Yes.
And to have this defender advantage, this 10x, let's say, defender advantage, you need to have bonds, like the bond requirements has to, like the bond at the second level has to be 10 times less than the
Yes.
bond at the first level,
Yes.
because otherwise multiple invalid roots at the first level can induce multiple bonds at the lower level. So you need to go, you
Yep.
have 3 levels,
Yep.
right? The first one, the second one, the third one, and each one of them has to be 10x the
Yes.
previous one. So
Right.
like if you start from the bottom and you estimate the cost of just the last layer, and then you go 10x, and then you go 10x again,
Mhm.
isn't this cost already similar to these 3,600?
Right, you can calculate
stake?
from top down or you can calculate from bottom up. You get a pretty similar result, at least for the parameters of Arbitrum 1.
Yeah, but like what I'm saying is Arbitrum has a very high TVL. So like it could
Yep.
be that delaying the protocol has a very high cost. But what
Yes.
about an orbit chain that has a very low TVL? Isn't the bond requirement kind of the same?
So what you get is it. So if you calculate bottom up, you have an option. There's a parameter here, and there's a cube root involved, which basically has to do with how much faster does the attacker's cost increase than the defender's staking requirement, right? Every protocol is going to have this issue.
I disagree with that. But
Sorry?
go. I disagree with that. Yeah.
Really?
I do. Yeah. Yeah. Really.
So explain to me how you can deter someone delaying the protocol by
Oh
a
no, no.
week
Sorry. I thought you
by
were talking
putting
about
down a stake.
I thought you were talking specifically about the advantage that you do need this 10x, 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 this cubic, specifically to give like a 10x advantage. With that, I do disagree. Not with the delay. Yeah.
All right, so I'm eager to hear this.
Oh yeah, sure.
You guys haven't published an economic analysis of your protocol that I know of.
No, but actually, you have analyzed it on the bold paper itself, and I think you came to the same conclusion, if I remember correctly. Yeah.
About your protocol?
Yeah.
Yeah, about the Cartesi protocol.
yeah.
Right?
Oh.
There is a section on the Cartesi protocol.
On the Cartesi protocol. I'm sorry. Yes, that's right.
Yeah.
Yeah, so I wanted to actually...
Right. I'm sorry. So that's right. I'm sorry. I lost my context there. Yeah, so the trade-off there is that if you're willing to have the delay last longer, right, if you're willing to let the attacker delay by... One of the constraints we set ourselves with Bold is that there was a quasi-constant upper bound on how much delay an attacker could cause
Sorry,
at
Ed,
any cost.
can you explain what
Yeah.
is the difference between like fully parallel
Yeah.
challenge protocol or like...
Versus a tournament style,
Yeah.
like Cartesi. Yeah.
Yeah.
So it's basically a trade-off of if you go with the tournament style approach, then an attacker who stakes more can cause longer delay, right? If you go with the bold approach, then an attacker can cause only an additional week plus a tiny amount of delay, no matter how much they stake, right? And that is the trade-off. And as we say in our paper, there's sort of a continuum there where there's a dial you can turn because a tournament doesn't have to be a binary one-on-one tournament, right? It can be different things. But you can, if you're willing to accept longer delay, then you can get a bigger advantage in attacker spending to honest stake ratio.
Yeah,
So
Gabriel.
there's a trade-off there.
Yeah, exactly. So I think in the end, that's the trade-off that we took
Yeah.
differently. We, on our side, we like aggressively optimize for what you call security and decentralization.
Yep.
So security in this sense is being this resistant to being exhausted in terms
Yeah.
of resources, and decentralization being how accessible it is to participate. Because in the end, the way we see this is that we want one single participant to be able to defeat anybody else.
Yep.
Could be like a nation state.
That's got to be a requirement. Yep.
Yeah. And the second one is that I want that single honest person to be you. I mean, I want you to be able to go there and participate. And I think it's very hard for that to be true if the bonds are very high. If it's,
Yeah.
I mean, sure, you have the staking pool. I'm sure it helps, but
Right.
there-
I mean, the bond has to be high if you have a lot of assets at stake, right? Because an attacker who's doing this attack, they can delay all withdrawals from the chain for a week,
yes,
right?
at
And
least.
so You figure out how much economic loss that imposes on users, right? That's going to be proportional basically to the value at stake on your chain. So more valuable chain, the stake has to be higher.
Yeah, true. But I do.
But
The thing we were prioritizing for is really like,
Yeah.
I want you to be able to participate, you know? And there is a cost, you know, like if you delay it a week, or in our case.
trade-off, and there's a really interesting trade-off design space here, right? Where you can sort of have hybrids between these designs.
Yeah. We did see your proposal, you know, like
Yep.
if you do like a tournament of bolts, I guess. Yeah.
Yeah, yeah.
And I think that do helps, yeah.
So there's some nice room for improvement here.
Yeah,
Yeah.
this I think is the point that I really want to drive home. You know, like I think we've made great progress. I think we were in a worse situation before. Now we are in a better situation, but I think there's a lot of room to improve.
Yeah.
And we can, I think, mix and match. On our side, we've been researching new techniques. We have one that's quite promising currently. We want your feedback once we publish it.
Yep.
Like you've given us before.
Likewise, yeah.
And like we've given you before. So this is like
All
part
right.
of the collaboration that I think this conversation is about.
So we're going to talk over beers.
Hey, absolutely, absolutely.
Amazing. Amazing. So,
Done.
like, to summarize very quickly the two designs, Ed, what is the advantage that the defender has over an attacker? Is it like 10x in
No,
terms
it's,
of funds?
it's an asymptotic advantage, meaning that the attacker's spending grows faster than linearly with the honest stake.
Okay, it's okay. And in Cartesi
It's logarithmic.
it's logarithmic,
Yeah.
right?
So logarithms they grow pretty slowly.
So it's
you know?
exponential in
It's
the
exponential.
Yeah.
Yes.
So you have an exponential advantage. It's good. Yeah. But
Okay.
it's
Yeah, so I wanted to move to Mark, to optimism, because like as we said, in one case is faster than linear, in one case is like exponential, the advantage is exponential. And the optimism for proof system seems to be like affected by extortion attacks in the sense that you need to stake for each invalid state root. Because like instead of having one big bond at the beginning, you start very slowly, like you start with 0.08, I think, at the beginning to like propose a state root.
Yep. And that buys you a week of delay, right?
No, because then, like correct me if I'm wrong, you need to put bonds for every bisection step. So
Yes.
every time you
Yeah.
bisect, you need to put bonds, right? So you start with 0.08, and then it grows exponentially. I think there is an exponential curve.
Yep.
So like the further you go into the bisection game, the more you need to stake,
If
right?
the attacker does, right? There's a very simple attack. The attacker just puts down one bond and then just goes to the beach. Doesn't do anything else, and the clock just ticks for a week. The attacker sacrifices that one little bond, they get a week of delay.
No, but
Right?
actually,
That's why it's important that the first bond be pretty large.
but it's like again,
Because
Mark.
the attacker doesn't go deep into the bisection. He just makes the first move and then pretends that he's being censored.
yeah. I actually have a question about that. You always say like one. I'm sorry.
Yeah.
Oh, I'm so sorry. Go ahead, Mark.
I
My
mean, what
bad.
if the
Yeah,
attacker
so
does that?
in practice,
Just makes the first
you know,
move and then does nothing else.
so we try to design the protocol to give good user experience, right? Like we shipped a protocol that anyone can make a proposal to when they are, you know, making an assertion about the L2 state, right? And if that is absurdly high, then, you know, not many people are going to participate. So like at, you know, 0.008 ETH, like anybody can make a claim about the withdrawal. And in practice, we're not like seeing delay attacks happen, right? And I think it's really important to focus on, you know, solving real problems for users and focusing on delivering like the most minimal, like viable thing that works. And today we're observing in production that it works. We may not have like a economics paper or anything like that about it, but it is working. And, you know, I would love to see someone come and attempt to like do delay attacks.
Could you just confirm that someone could get days of delay by sacrificing 0.008 ETH?
No, that's not correct, right?
So there's
Is that true or not?
based on the way that the clocks work, I do not believe that is true.
You don't think a party could just make a top-level move and then not do anything else?
No.
What happens?
So what happens is there's two different there's 2 different clocks for
Yeah.
both sides, right? And
Doesn't the other party need to get 3.5 days on their clock before they can declare victory in the game?
yes.
Yes, so that's 3.5 day delay for 0.008 ETH.
No, because like everything is in parallel, right? So like even if you like have multiple state roots, like multiple.
Just one attacker makes one claim, posts 0.008 ETH, then does nothing else.
You could just make a claim about the next block and then withdraw from that.
You can.
Yeah, I think the so
This makes
in
no
bold,
sense,
for
sorry.
example, you have a
Yeah.
1 week challenge period, right? And once somebody like raises a red flag, then you start bold, and then that takes another week. That's like the idea of it, right? Do you think they might be joining these
Now,
2
it only
weeks
takes
together? You see what I mean?
That's not quite right, actually. If there's no censorship, then it takes a week whether or not there's a challenge. So a challenge only buys the attacker the ability to censor the good guy in order to delay for a second week.
Yeah, but could you join those 2 weeks into one? You know, like could you take, I don't know, the adversary spent like 6 days, 23 hours to post the first challenge, and then you subtract, or rather add in your case, I think you add, your clock runs up, I guess, accumulates time.
Right, that's right.
And couldn't you add like the 23-day, the 6-day, 23-hour to the clock of the first claimer?
Yes,
you see?
that's what happens. That's what happens.
Yeah, so then
Yeah.
it's 1 week, no? Like, what additional delay are you buying?
But it's not an additional week, right? There's the honest party makes a claim at time 0, right? And let's say at time 7 days minus a minute, the attacker makes a claim, right? Now, 1 minute later, the honest party will win,
Yes,
right? Which is the time that it would have taken even if there was no attack.
exactly. So
Right, yeah.
If I burn one huge collateral, do I delay? Like, how much am I delaying in truth, It seems like 0, unless I
It's essentially
misunderstood.
0, yeah. All you get by burning is the ability to censor the honest party. Yeah.
Yeah.
Yeah,
Do you think they might be
because
in
of the
that
way
same
timers
situation?
work in bold, but that's not the way timers work in all protocols.
I see.
Yeah, but my understanding in optimism is that if you stake 0.08 and you go away, then the defender clock, which is 3.5 days, goes to 0 and you win. Like, you get no delays. Like, it is 3.5, you finish your clock, and that's it, right?
Yes.
Unless you're gaming the 3
so
the 3 hour.
at each step, it doubles. So the cost does add up pretty quickly.
Yeah, so again, in optimism, it looks like that you need to stake for each move that you make, right? And you have this
Crazy.
extortion attack in the sense that if the attacker has more fans than the defender, like you don't get more faster than linear advantage, you don't get exponential, it's linear or maybe even less than, or like linear with a low constant. So how do you see this problem that you need to defend a chain, you need more fans than the attacker?
Yeah, that is definitely an existing flaw or like problem, but that's definitely like a problem that we can solve with kind of rethinking the way that we do the bonds. We've been exploring ways to make a single move that is actually multiple moves and kind of compressing that into a single bond.
So like shorten the depth of the game.
Yes,
the
sure.
protection
Yeah.
game, Right.
And we've been talking a lot about like the dispute game itself. I also think a fault proof is made up, and we like to call it a fault proof rather than fraud proof, just because like no one here is committing fraud. Fraud is bad. So fault
Speak for
proofs.
yourself.
Yeah.
As opposed to fault,
Yeah.
which is fine.
I mean, faults are attributable. But
Fraud is also attributable.
Yeah.
definitely not me. I don't know about you. But so like a fraud proof really has like 3 parts, right? So it has like this bisection game, which we've been talking about, right? Where you kind of, make challenges back and forth. And then there's usually like a fault-proof VM, and then there's a fault-proof program.
Yep.
And at Optimism, we're really focused on, building out multiple proofs because we believe in multi-proof being like the path to becoming a stage 2 rollup, right? That's the only way that you can really remove the keys, right? You need to remove the risk.
Yeah, but like even with multi-proofs, like if you implement multiple proofs over the same protocol that is not really like solving this issue, like, you know, multi-proof is not going to get you to stage 2.
This
right?
is true.
You need first to like solve the issue, maybe with, you know, shortening the bisection game, I guess, using ZK maybe.
ZK is another
the last
solution
step,
here.
right?
Yeah. I think that this is like an open research problem. You can go to our specs. We have an open pull request that kind of describes one possible solution to this that the team has been working on. I think, again, it comes back to really like there's a lot of like theory around, you know, shipping something that's like perfect. And then there's like the path of like shipping the thing that works, right? And obviously we don't want to ship things that are like not secure, that just because we shipped it, like if it's broken and it allows for funds to be like stolen or like arbitrarily long delays, that's really bad. But in practice, we're seeing today, like we're not seeing any major issues. It's live today. Anyone can participate in it. If there was like an incentive to, you know, do this sort of delay, it would be happening. But taking all that into account, we also need to make sure that we design for, you know, the worst case scenarios, right? So worst case scenarios are really important. But the real world is complicated, and it's impossible to upfront know all the factors that are coming into play. Like, you know, with this whole like proof of whale sort of attack, you know, we could look at all of the economic actors that are, you know, the exchanges, for example, that are accepting, you know, funds deposited into their transaction. Like maybe they would be interested in like contributing to like the security of the chain. Like I have no idea today if the exchanges are running, you know, challenge agents, but they definitely should be if they're, you know, holding large sums of money on these L2s.
Yeah. So I want to move the conversation to John a little bit.
It's pretty remarkable.
Sorry?
I'm sorry, it's pretty remarkable what we just heard. I didn't come here intending to be spicy, but honestly,
No,
the
let's go,
attitude that
please.
we shipped something and it hasn't been attacked yet, and that's our theory of security?
It's optimistic.
It's okay to have different opinions.
I mean, if that's your opinion, that it's okay to just ship something and it hasn't been attacked yet, and that's okay?
Well, you should attack it.
Do it.
I have an ethical problem with just attacking it on mainnet.
Yeah. Yeah.
Okay, well, you can report a bug
Oh,
bounty.
actually,
We have.
I have a question for both of you. So, like, do you see your fraud-proof systems, like OP-Stock fraud-proofs and Bold, being used in low-value chains? Like, is it feasible? Like, can you lower, like in Bold, can you have like a feasible bond requirements for low-value orbit chains?
Yeah. Yeah, you don't get the same degree of asymptotic advantage against an attacker. But it certainly does work. You'll scale down the bonds appropriately for the lower value of the chain. But there are many chains that are prepared to do that. We expect them to go to Bold.
What
Yeah.
about optimism?
There's a major problem with scaling, you know, the fault-proof security to many chains. I think that it's going to need to be an iterative thing where as we release additional, you know, releases of the software, we need to like push the cost down as much as possible, because the end goal is to create a software stack that like commoditizes the ability to create a stage 2 rollup that anybody can just like very easily, you know, go to a website, one click, you know, set up the entire system. And yeah, I think over the next few years, it's going to be a journey getting there.
Yeah. So I mean, I think the question of how you pay for the fraud-proof protocol, if it executes, is pretty easy. You pay for it with the attackers slashed funds, right? If there's not, provided that you actually slash their funds and don't give them to the winner, then you always have funds available to cover the cost of the attack.
Yeah, but like you need to have those funds available somewhere. Like ready to be deployed on challenges.
Right, you need some honest party willing to stake
Willing to
whatever the stake amount is on that chain.
Yeah, of course.
Right, and that's universal. If you're in an optimistic rollup protocol, there needs to be someone willing to place one stake.
Yes.
Otherwise, you're not going to get anywhere.
Yeah.
Yeah, so like moving to John a little bit, like pioneer of like optimistic rollups. So what's what's your opinion like between, for example, single round fraud proofs like in Fuel, right? Fuel V1, or multi-round, like even in Celestia, right? Celestia is planning, it is supposed to have fraud proofs for two things. For data availability, like for, to prove that the data was incorrectly extended. So on the DA side, and also for state validation, because you want to have like clients that can like verify the state without executing everything. So like, what's your thinking about fraud proofs in general? Because I've also seen that you're trying to like move away from them. You want to like avoid all these issues that we're discussing, maybe go to ZK directly?
So yes and no. So I'll start with a bit of context on what you said, which is that so Celestia currently implements what's called bad encoding fraud proofs. So if the data was incorrectly erasure coded, then there's fraud proofs to demonstrate this. What there isn't any fraud proof of currently, or a ZK proof, is of the correctness of the state machine, correctness of the state transition. One of the reasons for not really worrying about this too much is that the whole point of Celestia is that the state machine is minimized. And as such, the difference between a light node that doesn't verify, specifically the Celestia state machine, and one that does, is on, maybe not in a blockchain VM, but on like consumer hardware, is relatively minimal. Like you can still run what we call a partial node that doesn't download any block data, but only verifies the Celestia state machine. You can still run that on the phone, just like you could run a light node on the phone. So sure, there's no fraud proof of correctness of state transition. That's not really needed at this time because the state machine is so simple. That doesn't mean it's not coming. And some proof thing is not coming. Of course, one is coming because it's always better to not have to verify that at all. But the point being that it's much less needed than a protocol like the Ethereum virtual machine, for instance, where literally the entire block is just execution, and it's very expensive. Okay, so that was the first point. The second one is with respect to distancing myself from fraud proofs to avoid this. So I actually wouldn't necessarily say that's the case. That may be the case, but maybe not for that reason. One of the things is a lot of what's being discussed here is this need for bond, this iterative game, all this economics around like multiple rounds and delays. But you can kind of eliminate a lot of this if you just have a fraud proof that's a single round. Because then you don't need challengers, you don't need anything like that. Just someone posts a fraud proof, if something is invalid, and then that's it. Then you're just done.
But what does it mean to have a single round? Does it mean that I need to prove like all the blocks?
Oh, I guess
transition?
let me clarify. So no. So a single round just means there's no interactive. It's completely non-interactive. There's no. It only requires one round of interaction. So as opposed to requiring multiple rounds, because what is being discussed with the arbitrum and optimisms, fraud proof systems, and multiple rounds, or you have one person making a claim, another person challenging that, and then you kind of play this game with multiple interactions until you get to the final conclusion. With a single round fraud proof, someone makes a claim, someone can challenge it, and the challenge is either successful or it's not successful, and then that's it. No further interaction. So this only requires a single round of interaction. The completely non-interactive thing are like the ZK proofs. So this single round fraud proof kind of gets around all of these issues. Now it has its own issues, as is tradition, and in the blockchain space, these things have enormous trade-offs between them. One of the major issues with single round fraud proofs is that if what you're proving in that single round is very large, which it could be depending on your protocol, then it could be very expensive to verify. For instance, if what you're proving is the execution of a single EVM transaction on a layer 2, and you try to prove that inside the EVM in your bridge contract, that would be really, really damn expensive to prove in the worst case. In the average case, maybe it would be fairly cheap, but we're not targeting average case because an attacker is obviously always going to do things in the worst case. And in the worst case, that could be just intractably expensive, and not just by slightly so, but like just completely not even feasible. So that's kind of one of the major trade-offs. But if you're doing something like, is a completely stateless, some bad erasure coding on Celestia, that is very easy to do in a single round prod proof. There's no complex logic. It's all completely stateless. You look at it, you just do erasure coding, and then you're done. So those are kind of applications where single round prod proofs are very useful. Now, with respect to where Celestia is going, I would say that there's a tendency towards moving towards ZK proofs. For no other reason, perhaps that. Okay, I guess I shouldn't say for no other reason. But one of the reasons that this is viable is that the Celestia state machine is simple, and ZK proofs are pretty good when what you're proving is simple, because then the proving overhead, and the complexity of writing a prover is much lower, and that ironically is kind of the best place to use ZK proofs when the thing that is being proven isn't super complex. When you're dealing with something like a Ethereum virtual machine, I would say ZK proofs are still a kind of a bit behind where fraud proofs are today.
Yeah, so like in Celestia, fraud proofs are shared in the like peer-to-peer network, right? They're
That is correct,
off-chain,
yes.
right?
That is correct, yes.
And what is the challenge period on Celestia?
I don't remember off the top of my head.
Like the order of
Let's
magnitude.
say let's say days on the order of magnitude, or day, or something like that.
1 day in the order of days.
I would say so. Yeah. I can't remember off the top of my head, but yes.
Okay. Okay. I thought it would be like much shorter if you're doing things off-chain.
There are arguments that it could be shorter.
Okay.
Okay,
let's talk about.
Sure, there are arguments.
Let's
that could
talk
be
about
shorter.
challenge
Maybe you
periods,
could
right?
release. Maybe you could like iterate on it and
Sure,
release
but-
a better version in the future.
Sure. Although, yeah, like the notion of challenge periods, you can say it could be shorter because it's off-chain. That's debatable. Sure, I'm sure this group would love to debate that. But also, just challenge periods on-chain. Also, do they need to be 3.5 or 7 days? It's also debatable whether they actually need to be that long. So it's definitely subject a lot of people have a lot of opinions on.
Yeah. So first of all, who came up with the 7 days? Do we know? Vitalik.
Yes.
Initially.
Yep. It originally came from Vitalik basically saying in speeches that 7 days would be long enough.
The 7 days will be long
Right.
enough.
Arbitrum, I mean, we're the ones who did this first, and you can give all kinds of reasons. There's a lot of pros and cons, but bottom line is, right, what Vitalik said was that if there was a 7-day directed censorship attack against some major protocol or application, that he thought Ethereum would do a social hard fork to fix it. Right? And that's where the 7 days originally came from. Bottom line, that's the real reason.
100% correct.
But so, like my understanding is that the challenge period has to take into account what is the amount of censorship that can
Yes,
happen on
that's-
one, right? And the assumption
right.
is this could go till 7 days, not over 7 days, right? Up to 7 days.
Yeah, so our threat model is that the adversary can censor for up to 7 days in total. They can start and stop, but sort of you can imagine the adversary has like a switch they can throw to put Ethereum into censorship mode where they control everything, but they can only use that for 7 days.
Yeah. So
Right? And we want to be secure against that model.
yeah, John.
So to clarify, then to expand on what Ed said, is that it's not that attackers can only censor for 7 days. It's that if, as Vitalik said, if they censor for 7 days or more, that it'll be detected and socially slashed. But like an attacker, you could censor for like a month if they want. They could have that power.
Okay, I see.
If
If-
it's more than
yeah.
7 days, it'll socially slash, and that's why it's okay to
I
have a
see.
threat model that says they can only do it for 7
Yeah.
days.
A party who controls enough of the Ethereum stake by stake weight, more than a third, basically can censor for as long as they want in a way that would be very detectable.
So like we've noticed this difference because like we review all the protocols, all the changes, and all the
Yeah.
rollups. And one like very interesting things that we noticed in the optimism upgrade was that this assumption of 7 days is not actually 7 days, but 3.5 days. So like you allow L1 to be censored up to 3.5 days. Because like you have 2 clocks, that's my understanding of the reasoning is that you have 2 clocks of 3.5, and if there is censoring, you want at most a 7-day delay, while in Arbitrum is 7 plus 7, right?
Right, it's 7
Gets to
days,
14.
right. That's right.
7 days for 1 clock.
7 days directed at the honest party.
Yes.
Yeah.
So like now we've kind of reduced from 7 days to 3.5, right? And this is kind of kind of worries me a little bit that we try to push this challenge period to be shorter and shorter. Because like now there is kind of an incentive for Arbitrum maybe to, or like for some Orbit chain to be competitive with the OP stack, and maybe some other chain was even like if we break, you know, this 7 days Oracle
It would be useful to
statement.
have an agreed upon standard here.
Yeah, like we need to agree on something, because otherwise we risk going into this race of reducing this challenge period to like, I don't know, 1 day with a few hours, right?
So I'll say, because this is based on L1 being able to socially coordinate, this is not something that L2s should set a standard on. This is something that the L1 should provide guarantees to the L2s for. And if it cannot provide this guarantee, that means it has a shortcoming.
Yeah, so
And what-
Sir L1.
Yep.
Can
Excellent.
How can we measure the censorship?
We have another Sir L1, right?
Oh,
yeah,
I guess that's true,
yeah,
yes.
that's true.
No, no, yeah, but
we
I
have
mean,
two L1s.
the Vitalik is on
Sir
Ethereum.
Ethereum.
How can we measure the censorship resistance of L1? And are there ways in which we can improve L1 censorship resistance to like reduce the 7 days? Like, is it like, do we need 7 days regardless of the censorship resistant properties of L1 because we need the 7 days to coordinate? Or like, if can we improve L1 censorship resistance to actually get down to like, I don't know, 1 day?
Right. So there's kind of two classes of censorship. There's weak censorship and strong censorship. Weak censorship is the stuff that we're used to: the builder censoring, the relay censoring, the proposer censoring. Turns out that this is not a big deal in the context of fraud proofs. And the reason is that even if like 1 basis point of the validators were not censoring, then you'd still be able to get stuff on chain within the 7 days. And you know, like even like OFAC censored transactions that you know, are pretty heavily censored. About 70% of the blocks are censored because of the builders. They just take a few more seconds to go on chain. So that's not a problem. The real problem is the strong censorship, where effectively you have a 51% attack.
But what do you mean by
I
50?
think we're losing your mic.
What do you mean by 51? Like, even if the 51% is censoring, like your transaction would still go through. Like, that's soft censorship. What do you mean by, sorry, like 51 strong censorship attack?
You got it?
Yeah.
I can explain hard censorship while you get your mic fixed. All right. So strong, basically strong censorship means that the attacker is suppressing blocks that have transactions they don't like. So they just deny those blocks enough
I see.
attestations.
Yes.
Or if they get enough they deny those blocks enough attestations so they can never be accepted, right? And so this is an attack that can last forever, technically, as long as the attacker controls enough of the stake. And that's why we talk about a social response.
Yes.
And my understanding is soft censorship is block producers censoring transactions from the blocks that they produce, as opposed to censoring blocks. Is that correct?
Basically, yeah. That's and that, as Justin said, the first kind, the weak censorship, is easy to deal with. It's a statistical argument based on assuming that some small fraction of proposers will propose uncensored blocks.
Now
Oh my God. What's going on?
Yeah.
So in terms of tools that can help against the censorship, generally we think about inclusion lists and encrypted mempools, but all of that is the weak censorship. Yeah. Really, the only tool that we have for the strong censorship is a social fork. But there's actually a small caveat, which is that there's some ideas to do what's called a semi-automated 51% attack recovery. So just like we can have light clients that are continuously doing data availability sampling, we can have light clients that are kind of continuously monitoring the mempool and just observing that transactions are not going on chain. And so like everyone's light clients can go beep, beep, beep. And so it's kind of a way to semi-automate the process of doing a fork. So for example, what could happen is that if all the clients are programmed that, if a transaction has been in the mempool sitting for 1 day, then they give a prompt to the user, like, do you want a fork? And the fork will happen, in 6 days, or in 5 days, I should say. So then, within 6 days, there's the kind of this semi-automated thing where people just need to press a button and it happens.
Yeah, but like, can these solutions actually shorten the challenge period for optimistic rollups, in your opinion? Or like, is 7 days, like 7 days should be the standard in all cases, regardless of inclusion lists or regardless of this mechanism?
So the second time round, so if we have this 51% attack semi-automated recovery infrastructure, and it turns out to work on the first attack, and we feel confident and good about it, then yeah, we can reduce the times for the second time round. But we're probably never going to have the first attack to come to happen, so we won't have the testing, the drill, I guess. Maybe we can do it on test nets or something, but it's a very new experience, right? Where we're like actually asking the community to engage socially. Like the only time we've had this was in the context of the DAO fork, and the way that people engaged was that when they were running Geth or the other client, I forget what it's, Parity, there was a flag. Do I want a fork or do I not want a fork? And that was a very like manual process for nerds, but like it could be made cleaner for the average user as well.
I see. Yeah. So to like conclude this panel, we've been talking a lot about fraud proofs, but my questions for all of you is there space for fraud proofs in the ZK era? Like, we're trying to ZKify everything. I know that you, Justin, are very bullish on ZK in general. Do you think it's like, what are we even doing here? Like, why are we discussing fraud proofs, right? Aren't we wasting time here, spending time on fraud proofs? Like, what's your opinion?
I mean, this is what I'm wondering as well. It feels like, where like 100 years ago, whenever the, Ford came up with his car, and like you have all the horse people still saying like, okay, what kind of food should we give the horse so that it's like 10% faster, and like, shall we exponentially enrich the hay or something? And like, no, just like embrace the future. Now, I do agree that if you had started 5 years ago, like the proper way to get started was with fraud proofs. And like, I think that strategically speaking, Arbitrum and Optimism and all the fraud proof teams have done the right step. But going forward, the new teams, I think, should be, and this is what's happening, like many more ZK rollups that are coming up than fraud proof-based rollups. And I think even the optimistic teams like Optimism are funding and doing R&D and are actively considering doing the switch.
Yeah, Mark, what's your opinion on the topic?
Yeah, totally. I think ZK is the future. Like Justin said, like shipping with a fault proof let us get to market more quickly. I think that over time, more people will adopt ZK technology. But I think it's like a cost thing, right? Right now, it's very costly to like run the ZK proofs. To generate them, right? And I think also something that's nice is like boring cryptography, right? Like if we look at TLS is like used in production, all over the internet, and they're always finding like crazy new like attacks in it, right? And they're constantly being fixed and they're releasing new versions, right? So I think that something that make me feel a lot more comfortable is having a boring ZK proof where we know that this scheme works. It's been around for a while. All the bugs get sorted out. Like even some of the best ZK people in the space, like the Zcash team, they had a bug in their protocol. Like I guarantee you, in all the ZK protocols out there right now, there's probably bugs hidden in them, and there's probably also bugs hidden in the fault-proof programs. It's just like, it's the nature of this. So it's about building resilient fail-safe mechanisms that can catch these bugs. So we're thinking a lot about like multi-proofs. So that's just like the idea there is how we can combine multiple distinct proof systems together And then that would allow us to remove the training wheels to move to stage 2. So
like your bet is that having multi-proofs with optimistic rollups is easier than with ZK rollups.
yeah, I think the design space for multi-proofs to ZK proofs is a little bit more tricky because now you're basically like doubling, tripling, quadrupling like the cost of proof generation. And until that is basically commoditized and pushed down to nothing, it's going to be pretty difficult to be generating that many proofs.
John, what's your opinion on
Yeah,
this?
so-
On ZK versus
Yes.
proofs?
So I have some opinions here before we let Ed do his thing. So there's a few things here. One of them is ZK maybe is the future, maybe not. We can debate it all day, but today, it's today, not the future. And 5 years ago, when these protocols started being built, people were saying even back then, ZK is the future. You should use ZK. You shouldn't use spot proofs. 5 years ago, and to this day, even today, there's still a lot of immaturity in being able to prove these kind of general purpose VMs in ZK and still have it be cost competitive, and still having it, or alternatively, latency competitive. So the notion that you should go with a technology that may be the future but isn't today is extremely risky to build a project on today. The second thing is that ZK rollups, because of the proving time and or latency, depending on how you trade it off, there will always be a larger overhead, larger latency than in optimistic system. And that's basically unavoidable. And this doesn't just apply to mainnet. The kind of most awkward part about these ZK systems is it also applies to non-economical domains, such as testnets. Right, you have a testnet, if you want to make sure your ZK proof is running, someone has to pay for that proof, and potentially it's extremely expensive because I know testnets can be very large and bloated. And you have to pay for that proof generation all the time, even though there's no money going on. Who pays for that? So there's a lot of things to consider, and the ZK space, maybe it's the future, but we're still very early. And it's very promising, and there's a lot of very exciting research going on there, a lot of very exciting, and honestly, the pace of improvements is astounding. But it's still early.
Yeah, so I kind of get this argument that we are not there yet with ZK, but we also not there yet with prop proofs. Like optimism just for prop proofs, and it appears that there are some issues that needs to be solved on the extortion attack side. Bold is not even released yet. So yes, we're not there with ZK proofs, but we're not there even with prop proofs, right?
In 2021.
Yes, but I still feel like we're kind of wasting time here. I don't think the argument was strong enough. So please, Ed and Gabriel, save us.
All right.
From this mess.
Here's what I think. We're doing a lot of work on ZK proving to understand feasibility and methods. We've hired world-class cryptographers. ZK proving is part of the future, I think, but it's not the only thing in the future. Yeah. And let me explain why I think a hybrid scheme that includes both ZK and optimistic components is the way to go. Right? We want it to be the case that a regular user on the equipment they have can run a node. Right? And we want that node execution to fully use that user's machine. Now, if that's the case, and if, as I think it's inevitable, proving is a multiple slower than execution, let's say wildly optimistic it gets to 10x. Right? That means that user's machine is 10x too slow to do ZK proving routinely on their machine. Right? People with higher end hardware willing to spend some more, maybe make some capital investment, they can do ZK proving at the speed of execution. Right? But you also want it to be able to be the case that that end user is a full participant in the protocol, and the guarantee we've given since day one that you can, any validator, and now you can be a validator, you can force safe progress from the chain. In order to do that, we need to let that ordinary home user with weak equipment take the optimistic path. Right? Yep. So if you have a protocol where you can make an optimistic proposal, you can have an optimistic protocol, but anyone can just swoop in and ZK prove the result and boom, it's accepted, I think you get the best of both worlds. And I think that's where it's going, that kind of hybrid scheme.
Gabriel.
Yeah, so I think like everything in engineering, there's no silver bullet. So if you ask me for tell you, I guess, what would be the future, I would say it's actually both. I think we're going to see like applications that gravitate towards ZK, the ones that I can pay for it, the ones that don't need a lot of throughput, and the ones that do need a lot of throughput will gravitate more toward fraud proofs. Because I think there's a core difference here, mainly in throughput and on hardware costs used to run these like expensive provers. And even if you like improve them ridiculously, I don't think you will ever be able to bridge this gap. And also, we are also improving, like on the optimistic side. Like execution is getting faster. We have strategies to make execution be as close as bare metal execution. So if you really need like this, a lot of throughput, I do think that ZK might not be like the best solution, but I think it will also be part of the solution because we're also working on ZK proving our own execution, but as a support for fraud proofs actually. So the step in the end of like all the bisections, we want it to be able to be many state transition functions, be like a very fat state transition function, and that does help us while designing these fraud proofs. But yeah, I think the end is a question of throughput and cost.
So I think we're about to finish, but before we finish, I want to do an intervention to thank the L2B team for everything they do to make this space safe and better. You guys are making a huge contribution. And on that, I think we can all agree.
Yeah, absolutely.
Thank you, guys. Thank you for everything.
I also want to thank Ed I want to congratulate Ed on all the success of Arbitrum. Arbitrum's a great project, and there's a lot of really cool things. There's a lot of really cool things that they're going to release soon, like Stylus and Time Boost. Yeah, so I'm rooting for you.
Thank you. Thank you. We're pushing each other and making each other better. Cartesi, yeah.
And Cartesi, yes.
Your project is very interesting. I'm also rooting for you.
Yeah. Thank you.
Thank you. Yeah, that was it.